Okay, this is problem 27 in section 1.4. This is a word problem, a distance problem, and I've got it set up here already. What we have is a guy named Johnny who lives in Memphis who wants to visit Ann who lives in the town of Hornsby. Now when John leaves, he's traveling at 50 miles per hour. It says 1/2 hour later, after Ann leaves, she goes towards John traveling at 60 miles per hour. And the two towns themselves are 80 miles apart. So the question is, how long after Ann leaves will they actually meet? Where in here will they actually see each other on the road and stop and pull over and say hey or whatever? So this is a distance problem, and I'm going to set it up like the book does, where I'm going to fill in this little grid where I've got the two drivers, Johnny and Ann, and I've got these three columns, each describing the rate and the time and the distance for each driver. Now they gave us the rates, so that was easy. Johnny's rate is 50 miles per hour and Ann's rate is 60 miles per hour. What they didn't give us were the times. That's where the labeling comes in. So we're going to go ahead and label John's time X because we don't know it. But it did say that Ann left a half an hour later, which means she's always been on the road a half an hour less. So her time is going to be described as X minus half an hour. So we're left with this distance box to fill in. But the good news there is, since rate times time equals distance, we simply fill in our distance box by multiplying the rate in the time box. Since John's rate was 50 and the time was X, then his distance can be described as 50X. Ann's rate was 60, her time is X minus a half, so her distance can be described as 60 times X minus a half. So we've got all that filled in, now we got to write the equation. So how do we do that? Well, keeping in mind that no matter where they meet along this stretch, together they will have had to have traveled the full 80 miles, whether one goes 10, the other goes 70, or whether they both get 40 miles. Either way, once they meet together, they will have covered the entire 80 miles. So I call this a total distance problem. So together they went 80 miles, which means we're going to write our equation by taking John's distance, adding it to Ann's distance, and getting the total 80. So algebraically, John's distance is 50x, Ann's is 60 times x minus half. We got these from the distance boxes. Make that equal to 80. And so there's our equation to solve, cleaning it up a little bit, multiplying the 60 through. Here we get 60x minus 30. And then doing some cleanup, 50 and 60x combines to give 110x. Next thing I want to do is get rid of the negative 30, so I add 30 to both sides, which ends up with the equation 110x equals 110, which is pretty simple because then x equals 1. But you're not done yet, because you then need to answer the problem. If you take that x equals 1 and go back to where all this labeling occurs, there's like 4 places you can plug in that x, but they only want one of them. If I plug it into this box, John's time, that would tell me 1 hour after John leaves they will have met. But they didn't want that. They wanted how long after Ann leaves will they meet. So we've got to take that x equals 1 and plug it in here. And if I do that, I get 1 minus a half, which is a half, giving me the final answer that it's 1/2 hour or 30 minutes after Ann leaves that they'll actually meet up. So the final answer to this problem is the half an hour or 30 minutes.